Welcome back to the Ultimate Statistics GCSE revision guide. So this is part two. And we're going to start off by talking about time series. So time series is a graph where along the x-axis we've got time and along the y-axis we've got another variable. So here this might be sales, it might be thousands. It's something that we can quantify. Now, the use of a time series is we can see both seasonal variation and trends over time. So we see here that for each third quarter, the sales go up. Now, this could be because they're selling coats. It could be something that's particular for that third quarter that might happen. It could be going back to school equipment where it is most prominent in this period of the year, so the third point of the year. But we can also see from this graph that over time, it's increasing. So if this was talking about sales, the company is getting more sales over time. Now, linked in with the time series are moving averages. So if you look here, we've got the same data as we had on our time series graph, just written out in a table form. Now we can see that we've got 2009 quarter 1, 2, 3 and 4, 10, 2, 1, 2, 3 and 4, and 11, 1, 2, 3 and 4. So it tells me, because we're dealing with trend data that has a 4-point system, we should use a 4-point moving average. So that means that we would take our 4 values here, we would work out an average for that, so we would add them together. That equals 120. We'd divide that by 4, so the average for those 4 numbers is 30. But our next moving average we would drop off this top value here and take in the next value down. So we'd start at 35 plus 52 plus 22 plus 16, which is 125. Work out an average from that, so we'll divide it by 4, which is 31.25. So the average for the next 4 numbers is 31.25. Again, if we're working out the next 4-point moving average, we get rid of that one. Look at the next 4 values, so 52, all the way down to 36, which will be 126. Work them out as an average, 31.5. So we're going to get our first 3 4-point moving averages. Now, if we take this back to our time series graph, we can plot those on our time series. Now, if we look here, we've got a 4-point moving average for these red bits. We plot it in the middle of that group. So we'd plot it between quarter 2 and 3, and we'd go up to 30. So in between 2 and 3, up to 30, it'd be plotted there. The next one, which is my purple one, it would be between the next one, so it'd be quarter 3 and quarter 4, and it'd be 31.25. Quarter 3 and quarter 4, 31.25, so here. And if we continue it, 31.5, so we're around here. Now this line going through those points, that gives us our trend line. So when we draw our trend line, we use our moving averages to get us the best possible trend line we have. So the next thing we're going to look at is choropleth maps, sorry. So these are ones that use colour. So that word there meaning colour, to determine values. So here below we have what's called our key. So we've seen them on stem and leaf. You should have a key for the choropleth graph as well. So here, the darkest means the highest percentage, the lightest means the lowest percentage. So I can see here that quite a lot of this area is dark, but quite a lot of this area is light. So whatever this percentage represents, so maybe percentage of people with degrees, lots of people or a high percentage of people have degrees here, but not many people here have degrees. Another use of them, and what you might see, is in this grid format. So especially in biology, where you're sampling areas for amount of wildlife or a particular insect, you might use it in a grid, and you can tell the highest proportions and areas based on that. So we've got our key here again. Now this is a past exam question where it asks you to fill in these 8 squares. So if I get my pen, we're going to fill those in now. So we've got a value of 4 here. So we look in our key. So that tells me it should be dashed lines for that one. Value of 3, again, dashed lines. A value of 1, well, that's just a dot in the middle. A value of 1, a dot in the middle, dot in the middle, dot in the middle, dot in the middle, and hashed lines. So you can be asked to fill this sort of choropleth mapping. Another map or diagram you might see is a population pyramid. So they call it pyramid because it takes a similar shape to those traditional pyramids in Egypt. Now, they often will be split into 2 sides. So here we've got males on the left, females on the right, and this is to do with some percentage for given age groups. So we've got age groups going up the y-axis and our percentage leading out both ways from 0. So it's going up in both those directions, leading off from 0. So if we pick one age group at random, say the 50 to 54, if we read it off, males have 3.6% and females have 3.7%. Now, if we were saying, for example, we want the total percentage for people under or 19 and under here, we would look at all those percentages underneath and add them up. So for males, for 19 and under, we would add up these values here. So that would give us 12, I believe. And for females, we would do the same. So the last diagram we'll be doing in this video is what we call stem and leaf. So that is our ones where you have a stem and the values are coming off to the side of it. We must remember our key. Now, for stem and leaf diagrams, what I tend to do, they have to be in order from smallest to biggest. So I rewrite my data from smallest to biggest and I cross it off as I rewrite it so I don't miss any. So we're going to start with 29. I think the next lowest is 32. Next one is 33. 35. We have 2 38s. We have a 40. 2 41s. A 42. 45 and 48. A 52. Oh, I've missed one. So straight away, because I'm crossing them out, I can see I've missed the 47. So I'm just going to shimmy my 48 along and put in my 47 as well. And then we finish off with the 55. As I say, by crossing them out up here and rewriting them below, it was very, very easy to see I missed one out. One of the biggest mistakes students make is to miss values out. So now we're going to draw our stem and leaf. So we're going to do our stem down the side and our leaves going across. We're going to start in the 20s. So we're going to split the number up. So 2 for 20, 3 for 30, 4 for 40, 5 for 50. And again, I think I might just put a line through these as I write them off. So 29, 32, 33. I tend to put commas between them, but you don't have to. And 238, so we write the 8 twice. We've got a 40 and 241, so 40, 241s. A 42, 45, 47, and 48. And we have a 52 and 55. Try and keep them in rows, so they're not all jumbled up all over the place. And the one thing we need to do is key so that anyone reading it knows what's going on. I always choose the first one as an example. 2/9 means 29. You can always put the key in a box to make it really obvious. When we have two stem and leaves and we're asked to compare, we'll be comparing the median. So in this one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So to get our median, we're going to add the 1 to that value and half of it. So it'll be 18 over 2, which will be 9. So I'm looking for the ninth value. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my median for the left-hand one, for shade, is going to equal 27. For the sunlight, again, we'll check how many values we got. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 again. So again, we're looking for the ninth value. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one there. So the median equals 41. So if you were doing a question where it said compare, you would say the median of sunlight is bigger than the median of shade. So they have, I don't know, taller plants on average. You also get stem and leaf which branch out both directions, a bit like the population pyramid we just talked about. You might be asked to compare a median or an interquartile range. So it'd be similar to what we did in this question. But we just need to note that the smaller numbers are closest to the stem. So see here we got the 1, the 2, the 6, and the 8 going in ascending order going out that way. Again, that's another way of students making mistakes. They write the numbers around the wrong way.